V. It's a V shape. Okay, so yeah, so the absolute value of x is a V shape, and that's something you do want to remember.
Got it.
Okay, so that's the parent function, and there's actually about 10 parent functions to know that you'll be learning about. That is kind of the challenge, is to know. So let's see here. All right, so now to do the transformations here, that's a little bit more involved here. So we have to talk a little bit about functions. So let me grab, we'll come back to this. It's like there's a lot of buildup to like actually doing this. So let's look at the so we got what they're saying is put x plus 1 in for x. So f of x plus 1 means put x plus 1 wherever you see an x.
Got it.
Right now, in terms of a transformation, we'll get to that, what that is in a moment, but that is the new function. Okay, so g, this is what, and that's what they want you to call g of x. They're saying just whatever your new function is, call it g of x. Is that okay so far?
So you're plugging in x plus 1 for x, and
Well, whatever it gives you, and that becomes your new function.
then g of x in this case would become your new function.
Yeah.
Got it.
All right, so now we can graph this. So we're gonna do the same thing though. We're gonna make a table, x, and then absolute value of x plus 1. And then I'm going to just give you the x values, -2, -1, 0, 1, and 2. So what you're doing is -2 plus 1 absolute value. So you have to do what's inside the absolute value first. So -2 plus 1. What does that become?
That would be the part, it'd be 1.
The final answer is 1. But -2 plus 1 is -1. Absolute value of -1 is 1. How about this one? -1 plus 1 inside absolute value. What does that become?
That would be 0.
Would be 0, or absolute value 0, which is 0. Okay. So it always returns 0 or positive. All right. So do the same thing for these next 3 values. Give me the output, please.
So for 0, it's 0 plus 1, the absolute value of that, which would equal 1.
Say 1.
Next one would be 2, the plug. Next one would be 3.
Okay. So these are now ordered pairs. So let me do them. Let me do it in a different color here. We'll go back to the graph, do it in red. So -2, 1, -1, 0, 0, 1, and 1, 2, and 2, 3. Okay, so we're going to plot these points here. And I guess I'll have you try to tell me what do you see here? What is how does, like, the black line to the red line, what do you see as happening?
It's like translated like a unit to the left.
Yeah, very good. So the yeah, so the transformation here is left 1 unit. So when you give the transformations, you have to specify the direction and the amount. Is that okay?
Got it.
And there can be a lot of transformations. There's, I don't know, let me think. I want to say there could be 6 transformations potentially. Okay. So in terms of the instruction, describe the transformation. We've done that. We wrote the new function g of x. We just didn't do it in the order they said. We graphed both of them. And now I have to state the domain and range. Okay. So uh, the domain is what in this problem? It's the x value. So are there any restrictions on the x values?
Yeah, so just be negative to positive.
Yeah, there's no restrictions on the domain. Okay, and then the range is the y value. So like the smallest y value is 0 all the way up to, well, how far does this go? The red one, it goes up forever. So 0 to infinity. Infinity is included, but 0 is, I'm sorry, infinity is a parenthesis, but 0 um, is just a bracket there. Any questions on that?
No, I think I got it.
Okay. So number 2. 2 here is really similar. We know what the parent function looks like. We know that the absolute value of x is a v. So you are supposed to know the parent function. Like you're supposed to know that, and like kind of like, when you roll out of bed in the morning, for when y is the absolute value of x, these 5 points go to these five points, and you know that it's a v here. Okay. Like you're supposed to know that. All right, any questions on that before we move on to
Sure.
transformation?
So here, let me.
Like that's just the original function.
And then would you multiply the half by, so when you're putting in the x into, or kind of confused what you do with the half.
Well, yeah, we're not there yet. I'm just making sure you're okay with the parent function.
Sorry, and f of x equals absolute value of x, which would
Yes.
just be.
Yes. So g of x is, it says take f of x. So f of x is absolute value of x, but then you multiply it by a half.
Oh, got it. You just multiply it by the, but wait, what you get from the parent function. Got it.
So the difference now is okay, when you put your numbers into this table, x and then g of x, which equals 1/2 absolute value of x, -2, -1, 0, 1, and 2. So this first one here is 1/2 the absolute value of -2. What is the absolute value of -2? It's 2, and then half of 2 is 1. Okay, and that's fine, no big deal. But the absolute value of -1, you're putting -1 in for x, is is 1, and then half of 1 is half. And so you start to maybe notice here that this could be a problem because um, you have um, you know, fraction points, and you don't necessarily want fractional points. All right, now 0, 1/2 absolute value of 0, half of 0, absolute value of 0, 0, half of 0, 0, half of absolute value of 1 is half of 1, which is 1/2, and then half absolute value 2 is 1. Now maybe you're okay to graph these half points. I don't really like doing that. So what I recommend is kind of noticing, well, okay, when it's even, -2, 0, and 2, I get a whole number uh, as an output here. To maybe add a couple of points, like maybe put in, and I can do this a little bit easier because I can slide it down. Like maybe see like, okay, well, -4 and 4, what does the output become for those? And so since you're an honor student, this is the kind of thing that they're expecting you to do. So can you give me the output for -4 and 4?
For -4 and 4.
Yeah,
So for 4, it would be 2 for
okay,
4.
good.
And then for -4, it'd be 2.
Agreed. Okay, and so these are better to graph. -4, 2 is better to graph. -2, 1 is 0, 0, 2, 1, and 4, 2. And your instructor appreciates that as well. Um, the they want you to graph. They want to be able to look at your graph and not it's weird. So -4, 2, -2, 1, 0, 0. All right. So when you're describing this, like I'm going to give you the official math words, but like when you go from the black to the red, and I'm just choosing black and red. You can choose any colors you want for this when you graph it. Um, what is it that um, what is it that you notice? Like how would you describe it to someone?
Um,
Okay, so do you see that it's flatter? Like that's kind of the
yeah,
word I'm looking for. Now we'll get to
yeah,
the right math word, but I was hoping you'd just say something's
yeah.
flatter.
That's what I was
Okay.
kind of wondering. Because
Now,
yeah,
the rule is though that if the number is outside the function, that's a vertical stretch, okay? Or it's a compress, okay? So it's a vertical because it's outside, and then use the word compress because this number on the outside here, 1/2, because it's less than 1.
got it.
Okay. Now this is where, depending on your instructor, they could either tell you the right or the wrong way to do it, and you need to ask them what they want here. You have to say by a factor of, and then the number that goes here, the correct answer is 2, but sometimes they just reuse this number. Because when you say compressed by a factor of 2, it's already presumed that you're cutting it in by 1 over this number. But a lot of teachers just make you write the word 1/2 or the number 1/2.
Got it.
Okay, now domain and range of the new function, the red there, could you attempt those for us, please?
domain is still negative infinity, infinity. And then the range would be it'd be 0, positive infinity.
Does it include 0 or not?
It does include 0.
Okay, very good. All right. So like so far, the takeaway should be you have to be able to graph what's called the parent function. And then we're getting into the idea of like what kinds of transformations are there? And there's a lot of them.
It's in the chat.
Take a look here. Um, but did you have time today to review these or or is it just like, I mean, sometimes after the test, they start a new
We didn't
section.
start this section yet. Just wanted to go over it a little bit before we do go over it, so I kind of understand it when we're going over it in class tomorrow.
Okay. All right. So, let's see here. The, number 7 here. It asks, where is the function, increasing? And then where is it decreasing? Okay, and it's increasing if it's going up and to the right. It's decreasing if it's going down and to the right. All right, so that it's you always think of it as traversing to the right. Like don't ever move to the left. It's always to the right. Okay. So the next thing to do is to look for any kind of breakpoints. So this right here is a breakpoint. So what I mean by that is a place where it switches from, increasing or decreasing or decreasing or increasing. Those are things to look for. Okay. And the other thing here is to think about is that this always refers to the X values, meaning your answer is the X value. Answer is X values, not Y's, X values. Okay. Like it doesn't matter that this goes to infinity up here. You care about what the X value is. How far left is this going? All right, so let me reframe the question here. So this thing is increasing. It's increasing. I'm just give you the answers here from 0 to infinity. So from an X value of 0 all the way to the right. So if you're going to the right, you're traversing the curve to the right, it is always increasing. It is decreasing. It is decreasing from minus infinity to 0. So from minus infinity, anywhere over here, all the way to 0, it is decreasing. So the answer here are the X values.
Got it.
Nothing to do with the y values.
Yeah, I think I understand.
Okay, so to see if you understand, I'm gonna have you try number 8. And we'll get to domain and range in a moment, but I think it's better to do more of just the, so all I want here to do, I just want you to do the increasing and decreasing on this one. And let me know when you got your answer.
Is it what for the uh, for the increasing, it would be y equals 3
There's
x.
no Y's. There's no Y's. Your answer is an interval like this. So where is the break point?
The breakpoint is 2 in this case.
2. So your answer is either 2 to infinity or minus infinity to 2.
This case, it would be minus infinity to 2, right?
For which one?
For decreasing.
Yes, I agree.
And for increasing, it would be including 2 to positive infinity.
So this is the next thing, is that it's always parentheses. Because at an individual point, it's neither increasing nor decreasing. So like at the end point, it
Got
can't be
it.
increasing or decreasing because it's like it's a fixed place in time.
Got it.
Okay, now let's look at the next one here together. Number 9, then we'll come back and do domain and range for all of them. But it's always good to kind of do a few in a row of just the one type and not mix in too many things here. So this time, and they don't have the arrows, but they really, you should presume that these go on forever. I believe. Now, I don't know. That's a good question here. Yeah. Do you think your instructor really meant to leave them off? Because there's no
Mm,
dots at the end. Let's just presume they're arrows for the
yeah.
moment. Okay. So just like in the previous problems here, there's like a breakpoint. That breakpoint is at -1. Okay. So give this a try again. Tell me where it's increasing, where it's decreasing. You only care about the x values, not the y values. Just wherever
Um,
wherever the x's are.
so increasing at negative infinity to -1.
Okay.
And it's decreasing from -1 to positive infinity.
Okay. Right. So I think you've got that. Now we can go back, talk about domain and range. And so for number 8 here, go back to number 8. The domain refers to the refers to the x values. Okay. So you just say, well, basically how far left to how far right. So how far left does this thing go? Like I mean, I know it goes up forever, but does it go left forever? And the answer is yes. Like even though it looks like it goes more up than it does left, it still goes left forever. So the domain here is minus infinity to infinity, because it goes left forever, and then this on the here on the right goes right forever. Yeah, does that like if you don't agree, like that, or it's unclear, please tell me, because I can't read your body language now if you think that that's okay or not.
Yeah, I think I get that. So the domain is still it's just the x values.
Yeah, I mean, one way I've shown this to students, and maybe you'll be able to appreciate this, is imagine like this line, this curve here, it just collapses onto the x-axis. So it just it just falls down on there. So you can see like this would fall here, and then this line here would fall on here. And how far would it go? Well, it would go forever.
Got
Like
it.
imagine you could flatten this onto the x-axis.
So
Well,
could it
what
ever be like the breakpoint is like, for example, could it ever be like the breakpoint is 2, but it doesn't go on forever in either in like one of the directions,
Yes.
and it
Yes,
goes.
there's lots of exceptions that you
And then in that case, you would like have to yeah, okay, got it. Here. Yeah, I don't think for any of the problems that you gave on this worksheet, it has it like that where it's only to like a certain point. Um, for all of them that on the notes sheet they're going to right now, it does appear that you put the arrows on like both the, or it's implied that it goes on forever. So yeah, the domain would be negative infinity, comma infinity. But in the range would probably have like a set point, wouldn't it?
so the range is different, right? The range is the y values, okay? And it's the min to the max, it's the bottom to the top. Like you got to figure out. And so for this one, kind of another way to do it is to imagine you're pushing everything to the axis. So like and then like you're saturating the axis, and like so see how it would be like this bottom gets pushed over here, but then all these other points, if you could imagine pushing in from the right here, that it would go up forever. But it really is the min to the max. So the minimum minimum y value is 3. How high up does it go? Infinity. And then because the 3 is included, you're gonna put a bracket there. Okay. So we spent a lot of time on that one. I'd like you to try domain and range for 9.
All right, let me put nine.
So if you need me to scroll up, I can, but this is it's
Alright, so yeah. So for the domain, the imply that there'd be arrows at the end of that of both
yeah,
the lines.
let's assume these go on forever. That would be a good assumption.
That would mean that the domain would still be negative infinity to positive infinity. It's implied that it doesn't stop at like a certain
Okay.
point. And then the range would be The range would be from negative infinity to -2.
So you have to, so when you're reading it out loud, you want to say, either includes -2 and then to put a bracket or a bracket,
Yeah,
-2
because
bracket, like, but that's really good the way you're doing it there. So fantastic. All right. Well, let me know if there's some other questions here you want us to go through.
she gave a couple of these problems, but this is one that I wanted to go over. She gave a couple of these ones, so this is one of the types of that question. You'll see it in the chat. All right, it's in the chat now. The next question.
Okay. All right, write the equation of G whose graph is a reflection over the x-axis of F. Okay, so there's quite a bit going on to like understand this. What I would like to do here is start with just like what are the transformations of f of x, and there's actually three of them. 1, 2, 3, and the order matters. Like a lot of students don't want to buy into that because they just think they'll just put them all down like that.
Well,
So I mean, and this is not really a fair question because you haven't even gotten into this, but I'm like wondering, uh, do you know what any of these transformations are?
Um,
It's okay if you don't. Just helps me to tell you to decide what we're going to do next.
then yeah, do you know what the reflection is? Obviously, the
Okay. All right, so let me do this here.
translation.
Let me go to my Desmos graphing calculator. I don't think we use this very much in geometry, but I would recommend graphing a lot of these using this tool because it's just so visual. Okay, so there's the original graph. Is that clear?
Yeah,
All right, and then what I like to do here is we're going to do them one at a time. So this +1, what does it do? What is the +1?
it
The red to the blue.
translates it 1 unit to the left, or
Right.
actually 2 units to the left.
Well, so if I put in 2, it's now 2 units to the left. So the first transformation is left 2 units. Okay. All right. Now, what does this negative do? So watch, what's really cool about this is I can just keep graphing stuff and I'll put a negative out in front. So going from the blue to the green, what is the transformation?
That it's reflected across the x-axis.
Yes. And the axis is important. You have to say the x-axis. Okay, now I'm writing these down for you, but that, like, you can't just say reflection. You have to say, reflecting over what? And all right, now the next one is this -1. Okay, so again, from the green to the purple, what do you see?
That it's 1 unit, or yeah, 1 unit translated down.
Down 1 unit. Good. Okay. So what's cool about this tool is our goal here is to reflect the purple over the x-axis here. So hopefully you can kind of see what it would look like. There'd be a point here where my mouse cursor is, then it goes, kind of up and to the right, and then up and to the left, right?
Yeah.
All right. So this is one of those where we just kind of play with, like, what do you want me to change here to see if we can get it to go that other way? Like tell me what to change here.
Take out the negative to make it.
Okay, so we take out the negative. That's looking good. That definitely flipped it, but it's down here now.
Then I'm sorry, what do you want me to do? Okay, here.
Well, the goal is to transform it over the x-axis.
So transforming it over the X, you have to translate it up by 2 units.
Okay. So what number goes there to the right?
What number goes to the right?
Yes. I mean, like you can see here, it's not -1. -1 puts you back down there. So what number could go out here besides -1?
0.
Okay, so there's 0. Is that a reflection over the?
Oh, actually, no, it'd be 2 plus or plus 1.
Okay.
Yeah.
So I agree that this is the correct answer. Very good. So now we have to talk about, well, how do you actually get the correct answer? So let's go back to the other screen here. Give me just a moment to get it all snipped in. Okay, and then let me go back and share that. All right, so you should be seeing my screen.
Yeah, I can see it.
All right. So like basically my question is, how do you go just looking at the equation now, we know the graphs, right? From going from the equation, how do you go from the purple to the black? Like you just said, I mean, you changed this, but like think of this whole thing as f of x. How do you go to this? Like what's the net change if you can tell me?
Um, plus 2.
Okay, but if we just take f of x minus absolute x plus 2 minus 1, if we just add 2 to it, I agree, we get to the plus 1, but
But yeah,
then,
you need to put you need the negative.
so if
You
you
need,
negate it though, you negate the whole thing. So what you gave me doesn't quite work, right? Because when you negate it, it ends up being absolute value of x plus 2 minus 1, and we want it to be plus 1.
yeah.
So is there a way, like what, like, and this is not really a math thing, but it's like, is there a way to go from the top one to the bottom one? And I'll give you, it is in what you just said, but it's kind of different. Like you're not that far off.
Would you multiply the negative out? Um, multiply the negative by the x plus 2 absolute value minus 1, multiply it by all of that, and then get
So if you negate f of x, you're taking the negative of this, and it becomes positive x plus 2 plus 1.
so you would multiply. So yeah, so to get that, you just need to multiply that out by the negative. Got it. So you wouldn't add 2 to get the positive one on that side. You would already get it from multiplying out the negative.
All right, so maybe time for another question, depending on how long it takes here. If you want to drop something in the chat real quick, please use that Desmos. I think you'll really appreciate it as a learning tool.
Mm. Alright, so let me put this, yeah, here, actually, that makes. Not everything, I don't really switch, but put it in the chat. So this one, I think we'd be able to go to D.
Let's see if we can get this
Yeah,
in real quick. Well, nothing with all these in. Let's see what I can comment on here. Sometimes that's enough here. Okay, so write a function v whose graph represents the graph. Okay, so yeah, I mean this is kind of a lot here to even begin to consider, but let me try to just give you some general guidance
so,
here.
yeah, so wouldn't it be the same kind of ideas as what we went over earlier with
Yeah,
the,
so when you see like x minus c, that's c units, right? X plus c is c units left. So, and then like f of x plus c is c units up. F of x minus c is c units down, or maybe your book uses k.
okay.
And then there's a bunch more. So there's up, down, left, right. Those are kind of the original ones to think about. But then there's also stretches and compresses and reflections. So there's a certain order also to take to learn these in. So probably should not necessarily get into that, but I assume you'll have a ton more questions on Thursday when we have our lesson.
Yeah.
So let's go ahead. Probably best to just stop right here for today. I don't know what's this.